Massachusetts, we have Professor Crumb. Professor, what do you have to tell us about today?
I'm Professor Crumblecake.
Okay, Professor Crumblecake. Okay, what are we going to be talking about?
We're going to be talking about numbers and how in the past it would have said to get, let's say the money was shells, let's say.
Okay.
So the person would just have like 2 logs and said, give me the amount of sticks and shells. So maybe they do a trade for 2 logs for 2 shells.
Okay.
Or something like that. And in the Romans, they were the first to make symbols like this, or like this, or any symbol that represents a number.
Okay.
They had different kind of numbers, but those do equal like 1, 2, 3, dot, 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 dot. They go on for forever. But and they have their own. They made their own system, and they were the first to make a system. So they're awesome.
Why do you think they chose? Why did we choose a 10-based system?
Because we have 10 phalanges, or also known as fingers or digits.
Okay.
Like this. This is your thumb. This is your all the rest of the fingers. This is your pinky.
Very nice.
And
you wanted to explain to me the basics
there
of
are
the...
like infinite other systems. They go on forever. The math system go on forever, just like the space between 2 numbers.
Okay.
Because you can have the 2 bases, and you can have the 3 bases, you can have the 4 bases, you can have the 8 bases, and you can have the 9 bases, you can have the 1,000 million system. They go on forever.
I understand.
Because the amount of numbers go on forever, the number of bases go on forever.
And can you tell us a little bit about...
They say that in that other codes like the 9-digit code or the 27 would have actually been better for us to do. Well, we already started with the 10, so it looks like the 10 is going to go on for quite a while longer.
Okay. Can you tell us a little bit about the system that we do use, the 10-based system?
Okay. So, for the 10-based system, which I will write down on this log, every number is times 10. So first you start out with, would be a power of 10. So here I'll draw a little small number line over, I'll make it go up to, like that. Okay, so this is, let's say, this is the 0. So behind each one, so here, this is 10 to the first power.
Okay.
10 to the second power. This is 10 to the 0th power.
Okay. And what are those?
And
we also know
here,
those. What are those places?
This is 10 to the negative first, and this is and this one over here is 10 to the negative second.
Okay. And what do we know those as?
We know them as 0.1, 0.01.
Okay. So are those? There's like a name. This is like the ones. Can you give me the?
So those are so these are the tens. These are the hundreds, and over here these are the tens.
Great.
These are the tenths. Sorry, I forgot to say that. And hundredths. And over here, this is...
Yeah, you have a little bit of Dr. Crumblecake. It looks like Professor Crumblecake. You have a little bit of room here. Would you like to be able to just... You could go down on the floor here and you could probably... Because we need to be able to see what you're doing really well. Okay. Go ahead here now that you're on the floor and we got a nice...
Okay, let's see.
What can you do? Teach me down here. Let me get down really low because...
So it's going to be useful when we do the metric system, but not useful in our system. So let me make an example over here. So there is, for a gallon, you just have to memorize this. Like for the cups and gallons and everything, you have to remember that there's a gallon, and inside of it, there are 4. And inside of it, there are 4 quarts.
You're right, there are 4 quarts. Nice.
And each quart has 2 pints in them.
Okay, you're right, there's 2 pints.
And each one has 2 cups in them.
Okay.
And you have to memorize that all by yourself. But in the metric, you actually can get help by what system we have.
Right, so we could just jump over by powers of 10?
Yeah.
And
Mainly use powers of 10. Unlike in here where we mainly use 2s and 4s.
I see.
Like over here is like the Kingdom of Gander. 4 queens, each one has 2 princesses, and each of them have 2 crowns. And so I know this from my teacher.
And do you know anything about scientific notation? If I had a very large number, how can I...
Give me one and I can show you.
Okay, let's if I said something was 36,000 miles away. How could that be right?
36, okay, and then it's 1,000, so...
Okay.
So now we're going to use scientific notation. What's this number right there?
Okay.
Okay, so now let's think. So in scientific notation, we're going to make this number 3.6 times. Actually, wait, I should just make a dot because you learn on growing to use a dot, to using an X, but later you're not allowed to use an X because of algebra, because the X is a common use variable, so you might get confused.
Okay.
I don't even know why we had to use an X when we were younger, but so times, so 3.6. So we're gonna see how many times we have to move the decimal. 1, 2, 3, 4 times 10 to the 4th power.
Great. And that kind of looks like the 10-base system too, right? Because it's similar, we're times 10.
Yeah.
Okay, and that really makes
You
it...
need to underline it so it's really because it's really super special.
Okay.
Get big underline.
Very nice. Okay, and then I think you were going to go over some fractions a little bit. I think you have some memorized, and then you want to talk a little bit about fractions and decimals.
Okay, so fractions and decimals, like I showed you before on the number line, are still part of the 10-base system because they're division.
Okay. And do you have any quick little fractions you have memorized that are?
I have 1/2, which equals 0.5. Wait, I made a mistake. It's quicker if you don't want to add the 0.
Okay.
Because if you're doing like a million decimals, then you don't want to add the zeros. Then I have 3/8.
What is that one?
That is point, no 0, 3, 7, 5.
Okay.
And then I have 1/8.
What's that one?
It equals 0.125.
Nice.
And then over here, I'm gonna please move the spotlight to over here because we have 7. These,
What does that one equal?
which equals 8.75.
Very nice. And Dr. Crumble Cake, could you explain the basic way that someone would go about changing a fraction to a decimal? What do you do?
It is fairly easy. So over here,
Yeah.
I will show you. So let's say we're trying to change 1/2, and we don't know what it is, not memorized like I do. So,
Okay.
like right there. But so we're gonna change it. So the answer is you have to do some division to get the answer. But it is 1 divided by 2. So it's the numerator divided by the denominator.
Okay.
And if you did it right, it should give you 0.5.
Perfect.
Because it only doesn't go in there any time. How many times does 2 go in? So we add the dot. How many times does 2 go into 10? It goes in 5 times. We write the 5 up there. That equals 10. 0.
Perfect. Well, I want to thank you very much for enlightening us today, Dr. Crumble Cake, Professor, and we'll come back to you another day.
Goodbye.
Goodbye.